Hey friends, Patrick God here. Thank you so much for dropping by, and I know I am pretty late to the party, but still I wanted to update this .NET Jumpstart course, meaning I already created this course back then with .NET Core 3.1, then I re-recorded the whole thing with .NET 5, and now I re-recorded this complete course again with .NET 6. So this is now the .NET 6 Web API and EF Core Jumpstart course. As the name implies, we are going to learn .NET 6 here, to be more specific, the Web API and also Entity Framework Core, Entity Framework Core 6 to be more exact, and then also JSON Web Token authentication. So regarding the Web API, we'll build a controller and use the repository pattern to get some data. To be more specific here, we are going to create a text-based role-playing game, a little fun game in my opinion, where users can register. Again, JSON Web Token authentication for logging in, for registering and so on. And these users then can create characters. And in the end, these characters will fight against each other. And we will do all that with, again, the Web API. We will create controllers here. We will use best practices, meaning, for instance, the repository pattern again, DTOs, data transfer objects, asynchronous calls, and much more. Regarding Entity Framework, we will store everything in a SQL Server database and cover all kinds of relationships, meaning one-to-one, one-to-many, and many-to-many relationships. And then finally, we will cover more than just CRUD, meaning of course we will implement all the create, read, update and delete operations, but on top we will also let these characters then of the users fight against each other. Automatically they will choose their weapon or their skill, and then for instance Frodo will fight against Raistlin with fireballs and the Master Sword, so lots of stuff, and maybe you know where I got all these ideas from. Anyways, this is what we're going to do in this course. Now here on YouTube, you will get an almost 2-hour preview of this complete course. So if you want to check it out first, then please keep watching and enjoy this tutorial here. Otherwise, head down to the video description and get the course now. Make sure to use the link in the video description to get a huge discount. Thanks again for watching already and maybe already for enrolling. Would be happy to see you inside the course. But now I stop talking. Enjoy the preview of the .NET 6 Jumpstart course. Welcome and thank you very much for joining the .NET 6 Web API and Entity Framework Core Jumpstart course. This course is meant to teach you .NET skills fast and efficiently, so you'll be ready to tackle any upcoming project with ease. This is what you will learn in the next couple of hours. In this chapter, you will prepare your machine with Visual Studio Codes and the .NET SDK, and then you will already create your first web API with .NET and even make your first API call. After that, you can create a Git repository for your project if you want to. Then we dive deep into the Web API. You'll learn about the Model View Controller pattern and best practices for a clean Web API structure and clean code. We'll get to asynchronous implementations with async and await, use data transfer objects. We will cover all CRUD operations, meaning create, read, update and delete, with the mostly used HTTP methods get, post, put and delete. We'll get to the details later. The following section provides persistence with Entity Framework Core. EF Core is an object relational mapper that will save all our changes in a SQL Server database. We will utilize code-first migrations to do that and again implement all CRUD operations. Then we'll cover authentication. Users will be able to register and log in and only see their related entities. We will use cryptography to hash the passwords and utilize JSON Web Tokens to authenticate the user with every subsequent web service call. Further on, we'll have a look at all types of relationships in a database. That's one-to-one, one-to-many, and many-to-many relationships. Each one needs its own kind of implementation. And finally, since in this example project you will create some role-playing characters, we will let them fight against each other all by themselves by choosing their weapon or one of their skills. And in the end, one character will have the most victories, and that's what we want to display. Alright, you see, there's a lot to learn. Let's start. As soon as the .NET SDK and Visual Studio Code is installed, we can already create our first .NET application, which will be a web API right away. To start, I created, as you can see here, a new folder called .NET RPG for .NET role-playing game. So please open this folder in VS Code. For that, we can just right-click and then open with code. Now, I assume you're already a bit familiar with Visual Studio Code. If not, feel free to have a look around. While you're doing that, it might also be a good idea to install certain extensions. So regarding the extensions, you can just go here in the toolbar. As you can see, I've got a bunch of extensions installed, but you do not need every single one. The ones I would recommend is, well, first C# for Visual Studio Code. This is by Microsoft itself, as you can see here, but this extension will also be suggested by VS Code as soon as you create your first C# application. It includes editing support, syntax highlighting, IntelliSense, go to definition, find all references, just have a look around, pretty useful stuff. Next is C# extensions by JOS Creative. The original version was implemented or was created by Jay Channon. Now this version was stopped and now it's the one by JOS Creative. And this extension, as the description says, hopefully speeds up your development workflow by adding some entries to the context menu, like adding a new C# class or interface. And then already the last one I recommend is the material icon theme. This, of course, is not mandatory. This one simply provides lots and lots of cute icons. So if you want, please install this one as well. All right, but now let's create our web API. We open a new terminal window. So we can go to terminal and then you terminal, or you check out the shortcut here for you. In your case, it is maybe different. I've got a German keyboard layout, so you probably have a different shortcut here. And I would say first we have a look what the .NET command provides. As you can see here with .NET itself, we can also add -h to get some help here. So .NET -h, and now we've got lots and lots of commands here. Interesting for us right now is the new command, create a new .NET project or file, but we also got the run command to build and run a .NET project. Also interesting is the watch command. As you can see here, start a file watcher that runs a command when files change. So as soon as we make changes to any file, the application will restart using hot reload, for instance. This is new to .NET 6 actually. Before the app rebuilt itself, and now sometimes there is the possibility that hot reload just reloads your application without rebuilding it. We will see this throughout the course, but just keep in mind that if you use the watch command together with the run command, you do not have to stop and start the application by yourself. You just save your changes and then the application should rebuild and you see the change already. All right, and now with .NET New, we see some of the available templates here, but to see them all, we can enter .NET New and then --list as it states here. So let's do that, and I think we need more room for that. So again, let's clear the screen and then .NET New and then --list. There they are. See lots of stuff. For instance, already .NET MAUI apps are available here. What we want is the web API, as you can see here. Blazor, also really interesting in my opinion. So lots of stuff we can do already with .NET. But now we want to focus on the web API. So let's use this command, meaning we enter .NET New and then web API. And with that, we open the Explorer here and we see that some files have been generated for us. So let's go through them real quick. At the bottom, we see the weather forecast class. This is just part of the default web API project. We don't really need it, but let's use this example in a minute. Now, in the meantime, you see this little pop-up here telling us that we should add some files, and of course, we want to add them. So we just click yes. And you should see now that we get this .vs code folder with the launch JSON and the tasks JSON. Both are configuration files used for debugging, source code formatters, bundlers, and so on, but not very interesting for us at this moment. So let's have a look at the program CS class. This is also new to .NET 6. Before we additionally got the startup class for configuration matters. Now everything is handled in the program CS. Here, for instance, we configure the app's services, so a reusable component that provides app functionality. As you can see here on top, we will register services here in the future so they can be consumed in our web service via dependency injection. Please don't mind all these buzzwords right now. Additionally, this class creates the app's request processing pipeline, meaning we specify how the app responds to HTTP requests. As you can see, we're using HTTPS redirection, authorization, and so on. With all these use extension methods, we are adding middleware components to the request pipeline. For instance, use HTTP redirection adds middleware for redirecting HTTP requests to HTTPS. I'd also like to mention that since .NET 5, we get the configuration for Swagger UI out of the box. This is actually done here and here. And with that, we get a convenient solution to test our API. We are already going to use this in the next lecture. Now, in the CS project file, we see the SDK, the target framework, in our case, .NET 6, and the root namespace, for instance. And this may be also interesting. This is the package for Swagger. So Swashbuckle ASP.NET Core is the package that is necessary for Swagger. All right, now regarding the app settings JSON files, there's this one and the development file here. We only need to know that we can add and modify some configurations here. Later, we will add the connection string here, for instance. But more interesting right now is the launch settings JSON file, where the current environment is configured and also the application URL. With this URL, we will find our running web service, as you can see right here. Now, the object and bin folders can be ignored for now. We find temporary object and final binary files here, but very interesting and often used throughout this online course is the controllers folder. And the first controller you see here is the generated weather forecast demo controller. We'll get to the details of controllers later. For now, it's only important to know that we can already call this get method down here. And I would say, let's do that next. Now in the terminal, we enter .NET watch run to start our application and already use the watcher and hot reload. Your default browser should open automatically, and in the terminal you see here's already the URL we've seen in the launch settings JSON file. Right here you see it's listening on localhost with the port 7103, and here it's localhost 5001. And again, let's double check here in the launch settings file. We also see the application URL. And now also important, we've got a launch URL, which is Swagger. And when your browser opens, here it is, you can already see the Swagger UI. So this is the launch URL here, and then we open the index.html. The Swagger UI will help us to test our web API, but let's forget about Swagger for just a second. You can already see the weather forecast controller here, but we can also access the controller with the address bar of Chrome. So when we go back to VS Code for a second, and to the weather forecast controller, we see the name of the controller, weather forecast, right? So without the controller term here. We also see the routing attribute. It's this thing here. And this thing defines how to access this controller. We'll discuss how routes work in a future lecture. But for now, we just copy the name. So weather forecast. Go back to Chrome. And then we enter the correct route. So simply weather forecast, hit enter, and finally we get the results. Okay, now let's go back to Swagger. You see the controller and the schema here. The schema is actually the weather forecast class that tells us how the result of the web API call will look. But now above, that's not only the controller, it's actually the get call of the web API. We can see the available parameters. In this particular case, there are no parameters. And we also see the expected result. That's this thing down here. It's in essence an array of this weather forecast model or object. And the best thing is we can try this out right here. So let's do that. We hit try it out and then execute. And here we see the URL, the request URL, which is the same thing we have entered in the address bar a minute ago. And we also see the result. Now what we can also do is we can see the result in the network tab of the developer tools. So just go to the three-dot menu here and then more tools, developer tools down here. You see the shortcut Ctrl+Shift+I, or you press F12 on your keyboard. There are the developer tools now. And now let's go to the network tab and select the filter fetch/XHR, which stands for XML HTTP requests. In your case, maybe you see all requests, all the results here in the network tab, but you can filter with fetch. And now you should only see the call. So let's try this again, hit execute, and there it is now, the weather forecast call. And when we click on it, you see in the preview, this is exactly the same result. Okay, great. So this works. And now let's move on and build our own web service. There's one little thing we may do before we start with the web API. Let's create a Git repository for our project. If Git is not installed on your machine, please do that first. And after that, on the left pane, go to source control. See it right here. And then choose initialize a repository, or you can also directly push the repository to GitHub. This is up to you, but the thing is that the listed changes are simply too many. When we test this here with initialize repository, you see there is lots of stuff and also lots of stuff we don't really need. For instance, you see the object folder here. This is stuff we do not want to see in our Git repository. So we need a so-called gitignore file first to ignore certain files and folders. So we open the terminal for that again. We can stop the app with Control and C. Get some room here. And now we just enter .NET new git ignore. And as you can see now, lots of file changes are not listed anymore because they are now ignored. And here you see also the file. There you see all the stuff that is now ignored in our project. Okay. So now we simply enter our first commit message like initial commit. And then we can either choose the checkmark here or go to the three-dot menu, go to commit, commit all. It's telling us that there are no staged changes. This means that usually you could decide if you want to commit certain files, certain changes, and leave the rest. For instance, let me show you this real quick. If I would just click on the plus icon here, then we've got only the gitignore staged, but we can also remove this again here and stage all the changes. See that? And now we can also, again, hit the checkmark or choose the menu here. Let's try it now with the checkmark. And we've got no message, no dialog that opens. Everything is committed locally now. And from now on, you can choose to commit your code whenever you want to get a clean history of your changes. I will do that too. Now, additionally, you can push your repository to GitHub So you can do this here, or down here you see this little cloud icon, published to GitHub. Let's try that. Make sure that you are logged into GitHub. I am, as you can see, this is my repository. Now I've already got a .NET-RPG repository because I did this already, or started creating this course with .NET Core 3.1. So let's change the name to .NET 6-RPG, and then you can choose if you want to publish this as a private or a public repository. For now, since I'm still in the recording process of this course, I will publish that as a private repository, but of course, when you're watching this, I already made this public. So let's hit private for now. And now I can open it on GitHub. And there is my repository. Awesome, that's it. Your code is now stored in the cloud. So far, you learned how to create a web API project in .NET from scratch and how to make your first API call. In the upcoming sections, we will create a new controller and models for our RPG, role-playing game, characters. Additionally, we will turn our synchronous calls into asynchronous calls, make use of data transfer objects, or in short DTOs, and change the structure of our web API so that it meets best practices. But first, let's have a look at the model view controller pattern, which is the foundation of all this. Model view controller, or short MVC, is a software design pattern that divides the related program logic into three interconnected elements. Let me explain what every single one of these three elements stands for and how they collaborate. We start with the model. You could also say the data. A character in our role-playing game is a model, for instance. It can have an ID, a name, hit points, attributes, skills, and so on. You as the developer know the code of your model, but the user won't see your code, and that's where the view comes in. The user probably wants to see a representation of the character in HTML, plain text, or amazing 3D graphics, depending on your game. In other words, the view is the user interface, or UI. To sum these two up, the model updates the view and the user sees the view. If the model changes, let's say our character gets another skill or its hit points decreased, the view will change too. That's why the model always updates the view. Now, what's up with the controller? The controller does the actual work. There you will find most of your code because it manipulates your data or model. In our case, it's the web API that will create, update, and delete your data. Since we won't have a view except the results of our calls in Swagger UI, we're going to build our application in the following order. First the model and then the controller. And we will always jump back and forth between those two. With the help of the view though, the user can manipulate the data, hence properties of the RPG character, with buttons, text fields, and so on. In a browser game that might be JavaScript code in essence, maybe with the help of frameworks like Angular, React, or Vue.js, or now also Blazor WebAssembly. This JavaScript code in turn uses the controller to do the manipulation and save these changes persistently in the database. The manipulated model will update the view, which is then again seen by the user, and the circle starts all over again. Well, that sums up the MVC pattern, and now we're going to build our first model. The first things we need are new models. We need a model for the RPG character itself and also a model for the type of RPG character. This means a character class like Barbarian, Monk, Necromancer, and so on. So first we create a new folder at root level and we call this folder models for our new models. For the character model, we will create a new class in this models folder. And again, if you have the C# extensions installed, you can just right click and then go to new C# class. And then we enter the name of this class and this shall be character. All right, and now let's add some properties. We can use the built-in snippet prop, hit tab once, and the first thing is correct an integer with the ID. After that, we add the name of the character, like that. And this is by default Frodo, for instance. Then we add another integer for the hit points. And let's say by default this is 100. Let's get some room here. Next is another integer, which is the strength value of this character. This should be 10. And then pretty similar to the strength, we add the defense. Also 10 by default, and also the intelligence. Alright, and now we will also add an RPG class property. This means the type of the character, but first, to be able to do that, we have to create a new enum for that. So again, right click, new C#, and then enum, and we call this RPG class. Now, of course, feel free to add any kind of role-playing class you want to add here. In this example, I use Knight, Mage, and Cleric, the most basic characters you would need, I guess. Some melee action, some magic, and of course, never forget the healer. So let's add the Knight, and then the Mage, and the last one, the Cleric. All right. And now when we have the RPG class enum ready, we can finally add it to the character model. So down here, another prop, this time of class RPG class, and we call this simply class. And by default, I would say this is a knight. Okay. Of course, as always, this is totally up to you. I used the knight here, but feel free to use a mage, a cleric, or any class you like. Alright, the first models are ready, and now let's add a new controller and make a get call to receive our first role-playing game character. To add a new controller, we add a new C# class in the controllers folder, right here. Now with the C# extensions, we could already create a prepared API controller. As you can see here, new C# and then API controller. But let's walk the necessary steps manually here first. So we create only a class, and we call this one character controller. All right. Before we can start implementing any logic, we have to make this thing a proper controller. To do that, we first derive from controller base, like that, and for that we also have to add the proper reference, and that'll be with control period. You see it here using Microsoft ASP.NET Core MVC. Now this is a base class for an MVC controller without view support, as the tooltip tells you here. Since we're building an API here, we don't need view support. If, however, we would want to add support for views, we could derive from just controller. But in our case, just make sure to add controller base. Now, after that, we have to add some attributes. And the first one above the class here is API controller. And this attribute indicates that a type and all derived types is used to serve HTTP API responses. Additionally, when we add this attribute to the controller, it enables several API specific features like attribute routing and automatic HTTP 400 responses if something is wrong with the model. We'll get to the details when we make use of these features. Now regarding attribute routing, that's already the next thing we have to add. So below the API controller attribute, we add the route attribute. Okay? That's how we're able to find this specific controller when we want to make a web service call. Now, after that, we open parentheses, and then in there the string we add to this route attribute is API, and then in brackets controller. This means that this controller can be accessed by the string API, this thing here, and then its name. So this is a convention. In our case, that would be character. So this part of the name of the C# class that comes before controller. You can see, by the way, here in the weather forecast controller, this string is different. We do not have the API string here. Again, this is totally up to you. All right, let's get into the body of our C# class. The first thing I'd like to add is a static mock character that we can return to the client. And for that, you also have to add the .NET RPG models reference. So up here, we would add using and then .NET RPG models. And since we're using C#10 here now with .NET 6, we could also add the global keyword like that. And maybe we can move this then to the program.cs file really on top here. And now the whole application knows this reference and we never have to add the using directive again. So back to our controller. We add this mock character now, so private static character. This should be a knight. Simply by creating a new character. And next we finally implement the get method to receive our character. So for that, we write a new method, public iAction results. This is what it returns. Call this method get, and then we return OK, and then the knight. So we return an iAction result because this enables us to send specific HTTP status codes back to the client together with the actual data that was requested. And now in this method with OK knight, we send the status code 200 OK and our mock character back. Other options would be something like a bad request 400 status code or a 404 not found. Let's have a quick look. You can see bad request, not found, and so on. All right, the code is implemented, and I would say let's test this now. We save everything, we open the console. Now let's use .NET Watch Run. And here is our application. We see Swagger UI and we first see an error. Still, let's try to call our web service method via the browser. So here in the address bar, we just enter API and then character, and there is actually our character. So this leads to the result we want. Now back to Swagger, let's open the console. Filter for fetch and XHR, so XML HTTP requests. Let's reload the page. And what does it say here? Ambiguous HTTP method for action .NET RPG controllers character controller gets. The action requires, or the actions require an explicit HTTP method binding for Swagger Open API 3.0. So what does this mean? Let's go back to Visual Studio Code here and now pay attention to the attribute that was added to our get method. Exactly, there is no attribute. So when we compare this to the weather forecast controller again, you can see down here we've got the HTTP get attribute, but it's not necessary for the character controller because the web API supports naming conventions, and if the name of this method starts with get something, for instance, get character, anything really, then the API assumes that the used HTTP method is also get. Now, apart from that, we only have one get method in our controller so far, so the web service knows exactly what method is requested. Still, as we now know, to help Swagger out, we have to add the HTTP get attribute. So let's do that, HTTP get. That's it. And now let's go back to Chrome. And there you can see everything works all of a sudden. So we see this method now, but we don't see any schemas or expected return types, right? So when we open this, there is no return type, no class, anything. Here we see one for the weather forecast controller, but not for our controller. So again, let's go back to VS Code, and we change the return type now from iActionResult to ActionResult, and then add the type character. Save this. After saving, we see this change was a root edit, so we have to restart our application. Hot reload does not work in this case. Of course, we want to rebuild. And now we see our schemas here, our classes. Swagger knows the character class, as you can see here, and also the RPG class enum. But thing is now, when we have a closer look at this enum here, we only see the numbers 1, 2, and 3. Now we can change that by configuring the JSON converter in the enum file. So one more time, let's go back to VS Code. And then to our RPG class enum. And up here now, we add the attribute JSON converter. And then with type of, and here this should be JSON string enum converter. And of course we have to add another reference, system text JSON serialization. Save this. Let's have a look again. And chances are we still don't see the names of the classes. In that case, we have to restart the app manually. So let's enter Ctrl R. And now we see the names of our RPG classes. Okay, and with all that, let's test our method. We go to our API character controller and the get method. You now see that this is the example value that is expected here. We try this out, we hit execute, and there is Frodo with the class Knight and all the other expected data. Perfect, so we can test the get method now without any issues. Now before we start with the new method, let's add another mock character to the controller by replacing the single character with a list of characters, because we will implement an additional method to return that list. So back to our character controller here, and now this shall be a list of characters. We call this now characters, and this is a new list of characters, and we already add 2 characters. The first one here is still Frodo as a knight, and the second one, let's give this one a name like Sam for instance, but it's also a knight. Format this a little bit. Okay, if necessary, by the way, we have to add the system collections generic using directive. Maybe this is the case for you. After that, we have to modify our existing get method, of course. We return the complete list of characters. So that'll be okay characters. And so we also have to change the return type of the action result. So this is now a list of characters. And before we get a single character, let's test that real quick. Let's just add an A for always now when we do a root edit. So it is rebuilding automatically. Now let's see, we have our new character method in essence, and you can see here now that the expected value is really an array. This is done here with the brackets, and when we try this out, hit execute, we get 2 characters, Frodo and Sam. Beautiful. Okay, now back to VS Code. Let's add another get method to return a single character. And for that, we can actually just copy this. And we return a single character now. Remove this. Let's call this method get single maybe. And we simply return the first one now for testing purposes. And you can already see I just saved this file. And while rebuilding, there is already an error. Terminal says conflicting method path combination, get API character for actions. Actions require a unique method path and so on. So this means the web API doesn't know which method to use because we now have two get methods, right? The get single method, this get method, and both only have the HTTP get attributes. And now that's where we have to add routing attributes. So let's add one to the first method and call the route get all. We do that similar to the controller with the route attributes. And then we say get all. We save that again. It's rebuilding. And now you can see we've got the API character method and API character get all. So you see with routes and then the actual string here, we can decide how to get to a particular methods. And here in Swagger, again, we see this as well. Let's try that now. We want to get all. Try that, hit execute. This is the expected result. And to get the single one now, you see no array here. So try this one out, hit execute. And we get Frodo back, the first character. Additionally, I want to mention that you can see the complete URL here, right? So API character now for the single character. And down here, you see the complete request URL with get all. Perfect. There's still one more thing we can do, which is combining the route with the HTTP method. So back to VS Code, and this is actually quite simple. We just replace the routes with HTTP get, like that. Remove the other attribute, and you're done. Back to Swagger. Actually, everything should work as expected. So we can try this, hit execute. And there's our result. Okay, now since receiving the first RPG character of a list can get quite boring, let's add an argument to our request. Now to get a particular RPG character, we could send the ID of this certain character to the web service. First, we add the ID to the mock characters in the controller up here. The default value is 0, so we just add the ID with the value 1 to the second character. So let's do it like that maybe. And now it's getting interesting. We add a new parameter to the get single method, and then we use the link to find the RPG character with the given ID in the list of all characters. So here we have int ID, and then here we say characters first or default, and then for the character C with the lambda expression here, we want to make sure that the ID of the character is the same as the given ID. So this method now returns the first character where the ID of the character equals the given ID. Now before we can test that, the last thing would be to add a route with a parameter to the HTTP get attribute, and the parameter has to be added in curly braces. So in here now we add a route as well, and here we add the ID again in curly braces. And that's it. The parameter in the route has to match the parameter name in the function itself. So ID and ID. And I would say we test that again. So let's save this. Back to Swagger. There it is. We see the parameter here already. Try it out. We enter 0. And here's the request URL. We get Frodo. What about 1? we get Sam back. Perfect. So notice that now we have to add an ID. So the controller name here and then the ID. Without this ID, this would not work anymore. And now, before we implement more methods in the controller, let's have a look at the various HTTP request methods we will cover in this course. The Hypertext Transfer Protocol, or in short HTTP, defines, as the MDN web docs put it, a set of request methods to indicate the desired action to be performed for a given resource. To this date, we can find 9 request methods in the documentation, and the most common ones are get, post, put, and delete. These are the ones that are covered in this course because you almost always can do everything that needs to be done with only these 4. Let's go over them shortly. The get method requests a representation of the specified resource. If you're using this request, you should only receive data from the web service and not send data to it. Of course, you might want to send certain characteristics to the service, like an ID or a string, and the backend then grabs the proper object from the database, but you won't send any objects to the service. You have already seen this when you received our RPG characters. Sending objects to the service in turn would be done with the post request. The post method is used to submit an entity to the specified resource, often causing a change in state or side effects on the server. This means that you might want to add a complete new RPG character to the database, for instance. Post means, to put it simply, add or create a new object and do whatever you want to do with that object in the backend. Usually, this new object will be stored in a database. The put method replaces all current representations of the target resource with the request payload. So this is in essence an update of the complete object. If you want to change a property of an RPG character, let's say just the name for example, you would send the whole object to the service and it would overwrite the complete entry in the database. Of course, there can be variations of that process, but the standard way is exactly that. Send an object to the service that already exists and update every property of this object. And finally, the delete request. You know it already, the delete method deletes the specified resource. So you send an ID to the service via the URL. The service usually looks up the corresponding entry in the database and erases it. If you rather want to do a soft delete, meaning just set a flag so that this entry will not be shown on the client, it's actually an update where you would then use the put request method. But to make one thing clear, nothing works automatically. You have to write all the service methods by yourself and define which HTTP request method has to be used by the client. You could in fact write a service method that uses gets, but then simply delete an object with the given ID. It's all up to you. Now, how do the CRUD, meaning create, read, update, and delete, operations match with the HTTP request methods in general? Maybe you know it already. To create an object, you would use post. Reading an object is done with a get call. Updating with put, and deleting, well, with delete, of course. Now that you know the most important HTTP methods, let's continue with the Web API by creating a controller method to add a new character. The idea behind that is that the client, in our case the browser, sends a JSON object to the service, and the service then creates a new character based on the JSON data. So let's start writing the methods. We start with public action results, and we return again a list of characters so that we see the result of the whole procedure here. When we added a character, we call this method simply add character, and the parameter here would be a new character. So character and then new character, like that maybe. Let's get some space here. All right. Now in the body of the function, we simply add the new character to the characters list. So that would be characters add and then the new character. All right. And again, after that, we return the complete list. So return OK, and then character, so that we can see that the new character is part of the complete list. Last but not least, we add an attribute to this method, and that would be the HTTP post attribute here. So HTTP post, like that, because then we are able to send data to the service. Now it's important to mention that the data or the JSON object respectively is sent via the body of this request. When we sent the ID to the service earlier, we did it via the URL, and now it's done with the body. That's a crucial difference. I would say we test that now. Let's save this. And now we see a post method. Now opening this and clicking at try it out, it already reveals an example object here we could send via the body, and the request type here is properly set to application JSON because we sent a JSON object to the web service. Now for our test, we can remove most of the properties and send a new RPG character with just an ID and a name actually. So let's remove this. ID should be 2 then, and here maybe we enter Percival. So let's hit execute, and down here now we see our complete list with the new character. We can actually double check that in the developer tools in the console. So I open this with F12. We go to the network tabs, already open in my case. And now let's just add another character with ID 3, maybe same name. We hit execute, and here it is. You see, this was sent to the service. This is the URL, post request method. Now the status code, the result is 200. Payload again, ID 3, name Percival. And now the preview, the results that is coming back or returned from the web API is this list here of our heroes. Just keep in mind, we don't store the data persistently yet. So when we add another character, we get 4 in total or 5. But as soon as we stop the web service and start it again, the list consists of the 2 initial mock characters, and the added characters are gone. Currently, we're doing all the logic of our web service calls in this controller here. The thing is, if an application or web service is growing, you might want to separate the work into different classes. Or if you need to do the same work over and over again, you don't want to copy your code and paste it into different controllers, of course. And that's where services come in. The controllers should actually be pretty simple and just forward data to the service and return the result to the client, nothing else. And by the way, otherwise, if they have lots of logic, these controllers, then they are called fat controllers. Now, to be able to do that, meaning forwarding data to the service and returning the result to the client, we will inject the necessary services into the controller. So we will use dependency injection. The great thing about dependency injection is that you're able to use the same service in several controllers. And if you want to change the actual implementation of a service, you just change one service class and you don't have to touch every single controller where you're using this service. We'll come to the details when we actually implement this stuff. So the client sends a request to the web API. The controller takes this request, calls the corresponding service. The service then does all the magic, like getting an RPG character from the database, for instance, and then the result goes back to the controller and then to the client. That's it. Apart from that, we can also introduce the idea of data transfer objects, or short DTOs. We already have models, but it's common to use these DTOs for the communication between client and server. The difference is this: DTOs are objects you won't find in the database. This means they won't be mapped. Models, in turn, are a representation of a database table. When we have a look at our RPG character model, later on we will see a table in the database that has exactly the same properties or fields. Let's say we add the field date created or is deleted. That's information the user does not need to see. In this case, we want to save this information in the database, but don't want to send it back to the client. That's where the DTO comes in. We grab the model and map information of the model to the DTO. There are libraries that do this for us, like AutoMapper, so we don't have to do this manually. Apart from that, we can also create DTOs that combine properties of several models. They simply give us more freedom in what we want to return to the client. And it's not only about returning data. You've already seen the example of creating a new character. In that case, we could use a DTO as well. So an object with certain information the client sends to the web service. The service then grabs these information and maps them to the actual model. We will use DTOs in future lectures so that everything should become clear. Alright, enough with the theory. Let's build the structure in our project now. So let's implement a clean structure now. We start with creating new folders. Now the first folder we create at root level is called the services folder. And in here now we create another one, and that would be the character service folder. Okay, and in that folder we create an interface and an implementation class. So right click, new C# interface, and that would be the iCharacter service, and the implementation class, new C# class, character service, which then implements the iCharacter service. Okay, now first to the interface, and this one gets 3 methods. In essence, the methods you already know from the character controller. So we return a list of characters with the get all characters methods. Then we've got character get character by ID. You see, I use a bit different names here. We need the ID parameter here, and the last one, list character at character, where we send a new character via the body. All right. Okay, now back to the character service. You can already see there are implementations missing. Now with Control period or the quick fix menu here, we can implement the interface automatically. The error is gone. And now we can actually jump between the character controller and the character service and copy and paste the code, but we remove the OK method call. So let's go to the character controller here. For the get method, we enter this thing here, so we just return the characters, and of course we will move them here as well. Then get a single character. That would be this method here. We return characters, and then the one with the given ID, and the last one here is the add character method, like that, and we return all the characters. Now the characters list, can actually cut that and put them up here. Now these errors are gone. And now regarding the character controller, we have to implement some more changes. First, we need a constructor, and we can add it again with the built-in snippet here. So CTOR and then hit tab. This is our constructor. And now in here, to make use of dependency injection, we add our iCharacter service as a parameter. So iCharacter service. And we call this character service. You see now that we need another using directive here, .NET RPG Services character service. That's the correct one. And additionally, we can, with control period, initialize this field from the parameter. And now we have our private read-only character service. So now we already inject our new character service into the controller. The list of characters is gone, that's why we have all these errors here. But of course, regarding the bodies of the methods, we have to make some changes, and that would be we have to call the character service now. So in general, the code inside the parenthesis of the OK statement here has to be replaced by the corresponding character service method. And in the get method case here, that would be character service and then get all characters. And down here, that would be character service get character by ID, and we also add the given ID, of course. And here then we remove this line, and here we add character service add character with the new character. All right, I would say we test this now. .NET watch run if you stop the app. There we are. Let's test the get all method, try it out, hit execute, and we're getting an error. Unable to resolve service for type iCharacter service while attempting to activate the character controller. So the web API wants to inject the iCharacter service, but doesn't know which implementation class it should use. So we better tell it. Back to Visual Studio Code, we have to open the program.cs file here. And here you can again see the registration of some services. And now we also have to register our character service. And to do that, we enter builder services and then add scoped. And then in angle brackets, character service, then character service, and that's it. And also, of course, we add the proper using directive here. So now the web API knows that it has to use the character service class whenever a controller wants to inject the iCharacter service. Now the beauty of that is that whenever we want to change that and use another implementation class, for instance, we just change this line and we're done. You don't have to change anything in the controllers injecting the iCharacter service. Now with add scoped, we create a new instance of the requested service for every request that comes in. There are also the methods add transient, for instance, so add transient, or add singleton. Add transient provides a new instance to every controller and to every service, even within the same request. And add singleton creates only one instance that is used for every request. We only need add scoped. Okay, so we save this again and then go back to Swagger. And now let's test this one more time. Hit execute. Maybe we have to restart the application manually. So Control R. Let's test this again. Hit execute. And now we don't get an error anymore. The get all call, for example, returns Frodo and Sam as expected. Now, what are asynchronous calls and why should you bother? Put simply, with synchronous calls, you would give a task to a thread, like fetching data from a database, and the thread waits for this task to be finished and wouldn't do anything else until the task is done. With an asynchronous call, this thread wouldn't wait at all. Instead, it would be open for new tasks, and as soon as the other task, for example fetching data from the database, is done, it would grab the data and return it. In our current application, this isn't really necessary. We have no database calls that take lots of time. Our tasks are done in milliseconds. Additionally, it's very likely that you have more than one thread available for your application. So even if one thread is waiting for a task, another thread can do another task. But in large applications with lots of users, it can really happen that all threads are busy. In this case, your app won't respond to a request anymore, which leads to a terrible user experience, and you may even lose users or even paying customers because of this. So this can lead to serious trouble. And that's why it doesn't hurt to know this and also implement it early in this project. Although the methods in the character service won't do anything asynchronous, they will later on when we fetch data from the database. So let's start off with the iCharacter service interface. Here we just add the task type to our return types. So in every single method, or for every single method, we add task and then the type. So task, and here as well. After that, we switch to the character service and then also add the task return type. So here and also here and here. All right, and additionally, we get these errors here. We have to fix them. We have to add the async keyword. So put it here, here, and also here. All right, now we've got asynchronous methods. Please don't mind these warnings here for now. The code will still be executed synchronously, but when we add Entity Framework Core with database queries later on, we'll have asynchronous calls. Okay, last but not least is the character controller. Again, we add the task type and the async keyword to every method, and then additionally we add the keyword await to the actual service call, and that's how we call an asynchronous method. So again, we've got task and then action result and so on, and down here now we call await character service get all characters. And last but not least, of course, the async keyword. Okay, now it's complete. Again, here, async task, and then action result character. We add await, and here as well, async task, and then await. Okay, that's it. Now going back to Swagger, everything should work as before. Actually, Swagger returns exactly the same results. Again, please don't mind that making all these methods asynchronously is not necessary for such a small project, but you're here to learn something, I guess, so that's how you should do it with large applications. Another practice you might come along in professional projects is to return a wrapper object to the client with every service call. Advantages are that you can add additional information to the returning result, like a success or exception message. The front end is able to react to this additional information and read the actual data with the help of HTTP interceptors, for instance, and we can make use of generics to use the correct types. Let's add that object to our models first. So we create a new class and we call this one service response. Okay. Now the actual class name would be service response with a type T, where the T is the actual type of the data we want to return. Okay, so now let's add some properties. First one is the data of this type T, and let's make this nullable. Then we add a bool for our success flag, which by default is true. And already the last one is a string with a message, and this is string empty. Okay, so the data of type T is, well, the actual data like the RPG characters. With the success property, we can tell the front end if everything went right, and the message property can be used to send a nice explanatory message, for example, in case of an error. Similar to the asynchronous implementations, we don't really need that now, but you will thank me later when you're working on bigger projects where these kinds of things come in quite handy. For instance, when you catch exceptions in a try-catch block, a service response like this might help you. Anyways, to make use of our new service response, we have to modify the return types of our character service and iCharacter service methods. So again, let's go to the iCharacter service. And now we simply add the service response class here. So after the task, we add the service response. And also here, and again here. Okay, and after that we do exactly the same in the character service. Here and also here. And of course we also have to make changes to the actual implementations of the methods. In general, we create a new service response object in every method and set the data property accordingly. So let's start with the add character method here. We say var service response is a new service response of type list character, like that. And then we add the new character. And after that, we say service response data is the characters. And here now we return the service response. Okay. Now to get all characters, we can simply return a new service response where we set the data to our characters. And we could kind of do the same here, but again, let's first create this service response here. New service response of type character. Then we say character is characters first or default, right? And then the service response data is this character, and in the end we return the service response. All right. And last but not least, we also add the service response as return type to the methods of the character controller so that we see the proper changes in Swagger UI. So up here now, we've got the service response. Let me copy this also here and here. Okay, let's have a look at Swagger. And we see two new types: character list service response and character service response. So a service response for a single character and a service response for a list of characters. Right? Can open this. Got the character here. And here the list of characters. Okay, apart from that, the results of the method look also a bit different now. For example, let's execute this one here to get all the characters. We see the data object now, or the data property with an array of the characters. We see success is true and the empty message. So you see our characters are wrapped in our service response. The front end could react to the new properties and provide a smooth user experience with toast notifications or something similar instead of presenting complex exception messages in the console, or worse, a frozen application in case of an error. You already heard about them, now it's time to use DTOs. First things first, let's create a folder at root level again called DTOs. So down here, DTOs, and then another folder called character for all the data transfer objects regarding the RPG characters. As already mentioned, the idea behind DTOs is that you've got smaller objects that do not consist of every property of the corresponding model. When we create a database table for our RPG characters later in this course, we could add properties like the created and modified date or a flag for the soft deletion of that character. We don't want to send this data to the client. So we map certain properties of the model to the DTO. That would be the case of returning data to the client. But it also works the other way around. We already created a new RPG character by only providing an ID and a name. So why not use a type that only consists of these two properties or other properties we want to use? This is even more important when you build a front end that should use a specific type of the creation of a new character. At the moment we have these two cases, receiving RPG characters from the server and sending a new character to the server. So let's create two classes called getCharacterDTO and addCharacterDTO. So right click, new C# class, getCharacterDTO, and also new class addCharacterDTO. Now regarding the getCharacterDTO, it should look exactly the same as the character model for now. So let's open this one here, copy that, paste it here. And I know it does not seem to make sense, but I don't want you to be overwhelmed by implementing anything Entity Framework related at the same time. So adding the DTOs is a good preparation. Now the addCharacterDTO looks a bit different. Let's say you want to send every property but the ID to the service, so we can copy the properties of the model again, but we remove the ID here, like that. Okay, and now that we have our DTOs ready, we can use them in our controller and service methods. We start with the iCharacter service again. So let's go to the service folder. Here's the interface. And instead of the character type, we now return the getCharacterDTO. So getCharacterDTO. We need a using directive for that. .NET RPG DTOs character. And we also use it here and here. And for the new character, this should be the addCharacterDTO. Okay, and then we do this exactly the same here in our implementation class. Okay, we add the using directive. We also have to make this change here for the service response. And then the last one here, the addCharacterDTO. Let's also real quick make the change for the controller. So here it's the getCharacterDTO. We add the using directive again. And the last one here, addCharacterDTO. Okay, we're done with that, but you maybe already have seen it. Here in the service, Visual Studio Code is not happy with that change. The types here, well, they do not really match, and that's where we have to map the DTOs with the model. It is time for AutoMapper. So we could map the objects manually by creating a new instance of the necessary class and then setting every property one by one. But the idea behind AutoMapper is that it's doing exactly that for us on the fly. But first we have to install AutoMapper, of course. Now there is this package here available on NuGet.org, and to install it, you can see it here. We can use the package manager or the .NET CLI, and this is exactly what I want to use, the .NET CLI. So let's just copy this thing here. We don't need the version, and now we open the terminal and enter .NET add package and then automapper.extensions.microsoft.dependency injection. Alright, and now when the installation is done, you can already see it here. This is the project file, and you see the package reference for AutoMapper version 11. Great. Now, after the installation, we jump to the program CS file first, and in here we have to register AutoMapper, and to do that, we can actually do it here. We enter builder services and then add AutoMapper. There it is. And as you can see here, this function needs a configuration, or there are also overloads. As you can see there, 11 it is. And we can give this thing an assembly, and we just give this now the assembly of our executing application by entering type of a program for the program class, and then assembly. And now when you have a look, let's add the semicolon first, and now we see we can also add a system reflection assembly argument. All right, and now the next step, to be able to use the mapping of AutoMapper, we now need an instance of the mapper in our service. So we go back to the character service, and we need a bit more space this time when we add all the mappings. And in here now we add a constructor and inject the iMapper interface. So we enter CTOR, hit tab, and now for the parameters we say iMapper, call this thing mapper with control period. We add the using directive for AutoMapper, and now we also say create and assign field mapper, and now the underscore is not here, but let's just add it real quick. This looks better now. Okay, now we can use the mapper to set the correct types to the data property of our service response. And I would say we start with the getCharacterById method. We use the map function for that. So what we have to do is we use the mapper here, then the map function. And what does it say here? We need a destination. So this would be then the class that we want to map an object to, and the argument is the actual source. All right. So in the angle brackets now, we enter the get character DTO, and the character is our source of type character, and we're done with the mapping here. All right. So again, we're using the map function, and first decide in angle brackets which type the value should be mapped to, and the parameter is the actual object that will be mapped. All right, now the changes for the other two methods are pretty straightforward. Now in the add character method, we first map the new character into the character type because it will be added to the characters list. So it's the other way around. Let's do that real quick. So mapper map. So this time we want to map to the character. model here, and to map the whole characters list in one line and give it to the service response, we use the select method of link followed by a lambda expression where we map every character object of the list into a character DTO. So we say characters select. Now for every character C, we say mapper map and then get character DTO, and the source is then the character, and in the end we turn this into a list. Okay, and actually we can just copy that without the semicolon and paste it down here as well. All right. Okay. So these are now the fixes, and now I would say we test that. So let's save everything. We open the terminal and enter .NET watch run. There is Swagger. And now let's test the get all method here. Open it, try it out, hit execute. And we're getting an error again. AutoMapper is saying missing type map configuration or unsupported mapping. So AutoMapper does not know how to map the character type into a get character DTO. Now you might ask, it's called AutoMapper, so why isn't this working automatically? Well, we have to configure one more thing, but then I promise AutoMapper is working fine. We have to create maps for the mappings, and this is organized in profiles. You could create a profile for every single mapping, but let's spare the hassle and just create one class for all profiles for now. So back to Visual Studio Code. And now here on root level, we create a new C# class and we call this AutoMapper profile. And this thing now inherits from profile, and we need the AutoMapper reference here. And now regarding the implementation, we need a constructor with no parameter and then create a map for the necessary mapping, and of course add further using directives. So first the constructor, AutoMapper profile, no arguments here. And in here now we say create map character get character DTO. All right, let's save that. First add the using directive, of course, save it again. And yes, we always want to rebuild if we get a root edit. And now let's test that again. Page is already reloaded. Try it out, execute. And now we are getting our knights. So everything works as expected. The same for returning a single character. So for instance, if we want to get the character with ID 1, this works as well. But what about adding a new character now? So let's close this and open this method. Try it out. Let's just use this object here. We hit execute. And again, a missing type map configuration or unsupported mapping is the error message we get. So we have to create another map. Let's do that. And this time we map add character DTO to character. So we can actually copy this, paste it here, and say add character DTO to character. Okay, and now let's test that again. Try it out. We hit execute. And maybe we have to restart our app manually. So let's do that real quick. Let's try this one more time. Execute. All right, that's nice. We test this and see that everything works, but you may also see that the ID here is 0. Now that's because the add character DTO does not provide an ID, and that's exactly what we wanted. Still, let's fix this by generating a proper ID ourselves. So in our add character method up here, we first create our new character based on the DTO and then set the correct ID by finding the current max value in the characters list and increasing it by 1. All right, so let's say our character, the new character, is the new given character, and then we say the character ID is characters max, and then again a lambda expression where we get the maximum value of an ID and just increase it by 1. And after that, again, we add this new character to the characters list like that. Okay. So let's test this one more time. Try it out, hit execute. And there is our new ID. This is from before, so there's an error. Maybe we can just rebuild everything so we really see that this works now. So post it. Oh, let me try the get all. We should see we've only got Frodo and Sam, right? And now in our post method, we hit execute. And we see now, oh, I did it twice. Okay, that's still okay. We see that even without sending an ID, the new RPG character gets the correct one. And later, when we use Entity Framework, it will generate the proper ID by itself. All right, we are done here. I know it was a lot and maybe way too much implementation for such a small project, but in large real-world applications, that's how it's done. To modify or update an RPG character, we have to add a new method to the iCharacterService interface, the CharacterService class, and the character controller. Let's first start with the interface here. The return type of this method will be a getCharacterDTO so that we can see the changes directly, and the parameter is a new DTO, the updateCharacterDTO. So task service response, and then get a character DTO. Call this method update character and update character DTO for the updated character. Let's add this DTO real quick. In our DTOs character folder, we create a new class, update character DTO. All right. And here we can actually copy and paste our properties from the getCharacterDTO again. So let's just copy this, paste it here, and we are done. And now we can implement the method in our character service. First, let's implement it automatically here. And there we are. So in here now, we first start with the service response, and then we try to find the RPG character with the given ID of the updated character in the characters list. And after that, we override almost every property of this RPG character one by one, meaning the name, the hit points, strength, defense, intelligence, and the class. And then we use AutoMapper to finally map the character to the getCharacterDTO and return the service response. All right, so again, we start with the service response getCharacterDTO. This is a new service response with the getCharacterDTO. Our character now is characters first or default, where the ID of the character equals the updated character ID, and then the mapping, so character name is updated character name, character hit points, updated character hit points, character strength is updated character strength, then the defense, intelligence, and the class. Then we set the data, so response data is mapper, map, get character DTO, character, and we return the response. And the last thing, we add the async keyword. All right, now off to the controller. There it is, the character controller. In essence, we can copy the add character method here, change the name, the service method, and the parameter, and also the HTTP method attribute, which is now HTTP put. So that should work. Now update character here, update character DTO for the updated character. Return type is also different, like that, and we return update character with the updated character. And I think there's an angle bracket missing. Yep, that should be it. So we return a service response with a get character DTO, call this method update character with the update character DTO, and the same here with the character service, and pretty important, of course, the HTTP put attribute for the put HTTP methods. All right, it's time to test this with Swagger. There we are, we see our put method. Now let's get all the characters first again for a reference. There they are. And now let's run the update call. Let's just keep this object here for the request. We hit execute, and we see that Frodo is now called string. Well, I guess it's good that this will be changed again when we restart the application. Now keep in mind that every single property has been updated. This means that the strength, the defense, and so on will be overridden, even though we may not send a value for these properties with the body. If you would run another update and leave the RPG class, Frodo would be turned into a knight in any case, because that's the default value. So you have to pay attention to how you design your front end in this case. Do you want to update single properties or all at once by receiving the current values of the character and save them back again, even though they did not change? All right, that was just a side note. And now let's try to update a character that doesn't exist. Just change the ID to 2 here, and then let's see what happens. So ID 2, and we hit execute. And we're getting a null reference exception. So we have 2 options now. Either we catch that exception with the try catch block, or we just check if we find a character in the characters list, or we do both. So let's go back to Visual Studio, and we start with the try catch block. So back to the service, and here in the update character method, we surround this thing here with the try block, and down here we add our catch exception X, like that. All right, and now in the catch block we do not want to return the response here, we return it here. But here what we want to do is we set the success flag to false, and the message to exception message like that, and that's it already. So let's test that again. Go back to Chrome and Swagger UI, try it out. We set the ID to 2, and we're getting this response now. So data is null, success false, and the message object reference not set to an instance of an object. So a possible front end can work with that. Maybe another message would be more suitable for the user. And alternatively, we can add a slight modification to the character controller. So you see, we are still getting a status code 200. Well, a character wasn't found, so maybe we can also return a 404 not found response. So real quick, in the character controller again, let's first get the service response. So var response is this thing here, and now we say if response data is null, we return not found response, and otherwise we just return the response with 200. Okay, save that and test it again. Try it out, ID 2, hit execute, and now you see the status code is 404 not found. Feel free to play around with that. For instance, you do not have to use the message of the service response only in case of an error. What about a success message like your character has been saved? Anyways, I would say let's move on with the next lecture. There's one little thing I want to show you regarding updating a character. Maybe you've wondered, why do we have to do this manually here? We could use AutoMapper for that as well. Yes, that's absolutely true, and I want to show you how this works here real quick. So instead of using this code here, we could write something like mapper map, and then you could either choose to use the angle bracket here and then the updated character here as an argument, or there's also the other option actually to use it like that. So we have two arguments here, and this is the source. So there you can see it. Yeah, the update character DTO is the source, and the destination is then the character type. So we use AutoMapper to map the updated character to a character, and additionally then we have to add another mapping, of course. So in here now, in the AutoMapper profile, we say create map update character DTO character. We save everything, and let's just restart the application manually here. Again, when we have a look and get all the characters, hit execute, we get Frodo and Sam. And now with the put method here, try this, and we use 0 for Frodo, update all the properties here, we hit execute. And we see now that this is the response, ID 0, everything is updated in essence. The name of Frodo is now string. We can double check when we execute get all again. See that here, no Frodo anymore, and no hit points, no strength whatsoever. And now regarding the case, you'd only want to send specific properties here. So let's say we've got ID 0. And the name now again is Frodo, and we want to turn this guy into a mage, and we hit execute and add the comma here and add execute again. You see now it's Frodo class is mage, but also the hit points, the strength, and so on, this has also been changed because these are the default values. And again, we can double check that by getting all the characters The mage is the proper update, but this actually, we did not send this to the server, to the web service, but still we have these values. So really pay attention when you do this. How would you want to do this? You can use AutoMapper, but still you have to pay attention to the properties you do not send to the web service, and you have to decide, do I want this actually, or do I not want to update every single property? And in that case, maybe it's better to not use AutoMapper and just update all the properties manually. Alright, now I will discard all these changes and then we move on with deleting a character. Now to delete an RPG character, again we have to make modifications to the iCharacter service interface, the character service, and the character controller. So first in the interface here, we add a delete character method with an ID as an argument, and let's return the remaining characters. So actually, let's just copy this thing maybe here. So we return the list of our characters. We call this delete character, and here it's only an integer, the ID. And now to the service. Up here, we implement the interface. And where is it? There it is, actually. Okay. Now, regarding the implementation for this method, we can copy the code of the update character method and just make some changes. So let's have a look here. Copy this. And paste it here. Now the first thing we add is the async keyword, all right? And then we fix the service response because we return a list of characters. So a list get character DTO, and also here a list of get character DTOs. And then instead of first or default, we could use first, like that. Now the difference is that first or default will return null if no matching entity was found, and first throws an exception, so let's make use of that. And if however a character was found, we remove it from the list with characters remove character. So we can actually remove everything here, and we say characters remove character, and of course we also have to remove the updated character here and use the given ID. All right, and after that we return a mapped list of the remaining characters, similar to the expression in the get all characters method or the add characters method with the select. So again, response data is characters select, and then for every character we say mapper map get character DTO, and then for all the characters, and in the end we turn this into a list. All right. Now the controller method is a combination of the get single and update character method. You can copy the get single method in essence. So let's do that here. And let's change the name to delete. And also we change the attribute to HTTP delete, but we need the ID here as well. And now the body, and that's why we can copy this, almost the same as in the update character methods. Of course, we now want to call the delete character method with the ID. And we also have to change the return type here. It is a list of get character DTOs. All right, and this should be it. Let's test that with Swagger. So we save this, and there is already our delete method. Let's try that real quick with ID 0. We hit execute and we get the rest of the characters back, which is Sam. Perfect. This works just fine. Our web API with all CRUD operations is done. And now it's time to save the data in a database with Entity Framework Core and SQL Server. So if you made it this far, then you are definitely ready to get the complete course. You've got what it takes to build a complete backend application with .NET 6, a web API, Entity Framework Core, JSON Web Token authentication, and a SQL Server database. So everything is covered in this course. Again, if you like this tutorial, I would really appreciate it if you check out the link in the video description to get a discount on the complete course and enroll now. Lots of people are already happy, and actually I get feedback that people got jobs, real .NET web development jobs thanks to that course. So again, maybe this is something for you, would really appreciate it. Apart from that, some YouTube stuff here. I would really appreciate it if you hit the like button and subscribe to my channel if you like this video of the .NET 6 Jumpstart course. Additionally, if you want to get more courses and get early access discounts whatsoever, then maybe you want to subscribe to my newsletter. So this would be really nice. I promise I won't spam you. At most I send an email once a week usually. And the last thing now, people, I forgot, no, this is an empty teacup. So thank you so much for all your support, guys. I love every single one of you. If you want to support me too, maybe you just want to get the course here, then head down again to the video description and check out the link for the .NET Jumpstart course. Otherwise, I would really appreciate it if you get me a coffee or a tea, whatever it is. And again, for that, you can check out the links in the video description. All right, and for more videos, of course, check out the thumbnails here on the side. Maybe you want to have a look at other videos, other course previews, whatever it is on my channel. Would really love to see you hanging out here on this channel, and maybe we can get to know each other. So this would be really nice. Thank you again so much for watching. Thank you so much for your time, and I hope I see you next time. Take care.